Good morning, everyone. I am Nandani from Department of Computer Science with Cyber Security from Dr. S.N.S. Rajalashmi College of Arts and Science, Coimbatore. Now I am going to talk about the topic Advanced Encryption Standard AES. Advanced Encryption Standard AES is a specification for the encryption of electronic data established by the US National Institute of Standards and Technology NIST in 2001. AES is widely used today as it is a much stronger than DES and triple DES despite by being harder to implement. Points to remember: AES is a block cipher. The key size can be 128 slash 192 slash 256 bits. Encrypts data in blocks of 128 bits each. Working of the cipher: AES performs operations on bytes of data rather than in bytes. Since the block size in 128 bits, the cipher processes 128 bits or 16 bytes of the input data at a time. The number of rounds depends on the key length as follows: 128 bit key 10 rounds, 192 bit key 12 rounds, 256 bit key 14 rounds. Creation of round keys: a key schedule algorithm is used to calculate all the round keys from the key. So the initial key is used to create many different round keys which will be used in the corresponding round of the encryption. The block diagram is plain text 128 bits, pre-round transformation, round 1, round 2, etc. and round n. Ciphertext 128 bits. Key expansion: each round conducting the 4 rounds K0, K1, K2 and Kn. Encryption: AES considers each block as a 16 byte 4 byte into 4 byte equal to 128 grid in a column major arrangement. Each round comprises of 4 steps: subbytes, shift rows, mix columns, add round key. The last round does not have the mix columns round. The subbytes does the substitution and shift rows and mix columns perform the permutation in the algorithm. Subbytes: in this step, each byte is substituted by another byte. It's performed using a lookup table also called the S box. Thus, substitution is done in a way that a byte is never substituted by itself and also not substituted by another byte which is a complement of the current byte. The result of this step is a 16 byte 4 into 4 matrix like before. Shift rows: this step is just as it sounds. Each row is shifted a particular number of times. The first row is not shifted, the second row is shifted once to the left, the third row is shifted twice to the left, the fourth row is shifted thrice to the left. Mix columns: this step is basically a matrix multiplication. Each column is multiplied with a specific matrix and thus the position of each byte in the column is changed as a result. Add round keys: now the resultant output of the previous stage is XOR with the corresponding round key. Here the 16 bytes is not considered as a grid but just as a 128 bits of data. Example: plain text and ciphertext round 1 and last round. It will rounds 4 subbytes, subrows, mix columns, add round key, and next round key subbytes, sub bytes and after our round key. After all the rounds, 128 bits of the encrypted data is given back as output. This process is repeated until all the data to be encrypted undergoes this process. Decryption: the stage in the rounds can be easily undone as these stages have an opposite to the in which performed reverts the change. Each 128 blocks goes through the 10, 12 or 14 rounds depending on the key size. The stages of each round is description as follows: add round key, inverse mix columns, shift rows, inverse subbytes. Inverse mix columns: this step is similar to the mix column step in encryption but differs in the matrix used to carry out the operation. Inverse subbytes: inverse X box is used as a lookup table and using which the bytes are substituted during encryption. Applications: AES is widely used in many applications which requires secure data storage and transmission. Some common cases include wireless security, database security, secure communication, data storage, virtual private networks, VPNs, secure storage of passwords, fill and disk encryption. Thank you.